Have you ever cracked open an old radio or maybe your computer and seen those tiny little components covered in colorful stripes? They kind of look like tiny pieces of candy, but they're actually speaking a secret language. Today we're going to learn how to read it, and you'll see just how brilliant it is.
I mean, seriously, these things are everywhere. They're hidden in plain sight inside pretty much every piece of tech you own. They're absolutely fundamental, but what are they actually doing? And more importantly, what's with all the colors?
So, to understand the code, we first have to get to know the component itself. Let's solve this tiny, striped mystery once and for all. Okay, so this little guy is called a resistor, and its job is, you guessed it, right there in the name. It resists the flow of electricity. A great way to think about it is like a valve on a water pipe. It controls just how much current can get through, which is super important for protecting delicate parts and making sure everything in a circuit gets exactly the right amount of power. They're totally essential.
Here's the catch, though. Not all resistors are created equal. They have different values. But just look at them. They're tiny. There's no way you could print 1,000 ohms on the side of one. So this created a really interesting problem for engineers, and it needed a very, very clever solution.
And that clever solution? Well, that's what this is all about. A system so smart and effective that it became the universal standard for the entire electronics industry.
You see, instead of trying to print tiny, unreadable text, engineers came up with a color code. It's like a language that lets you identify the value of any resistor in just a couple of seconds. You just glance at it and you know. It's simple, it's elegant, it's just brilliant.
And this right here, this is the Rosetta Stone. This is the decoder ring, the key to the whole thing. Every color maps to a number, either a digit, a multiplier, or something called tolerance. Believe it or not, this one chart is all you need.
All right, now that we have the key, let's actually learn how to use it. Don't worry, it's easy. I'm going to walk you through how to read a standard resistor, step by step.
So for a really common 4-band resistor, it's a super simple process. First thing you do is find the gold or silver band. That's your tolerance band, and you always put it on the right. Then you just read from left to right. The first two colored bands are your first two digits. That third one, that's your multiplier. And the last one is that tolerance value we talked about. See? Simple. Okay, theory is one thing, but let's actually try it out. Let's decode a real-world example together right now.
All right, imagine you're holding a resistor in your hand, and the stripes you see are brown, black, red, and gold. We've got our chart, we've got our steps. Let's figure out what it's telling us.
Okay, first band is brown. Let's look at our chart. And yep, there it is. In the digit column, brown is a 1. That's our first number. Simple as that.
Moving on, the second band is black. Let's go back to the chart, and black corresponds to the digit 0, so that's our second number.
So we just put those first two bands together. Brown for 1 and black for 0. That gives us the number 10. We are already halfway there. Now for the third band, the multiplier. In our example, it's red. Looking at the chart, we see that red in the multiplier column means times 100. This basically just tells us how many zeros to add to our number. So we take our 10 from the first two bands and we multiply it by 100, and that gives us 1,000. The unit we use for resistance is called ohms. So what we have is a 1,000 ohm resistor.
But hold on, we're not quite done. We've got that last band, gold. This is the tolerance. Gold tells us that the resistor's actual value is guaranteed to be within plus or minus 5% of that 1,000 ohms. It's just a measure of how precise it is.
And there you have it. Brown, black, red, gold equals 1,000 ohms with a 5% tolerance. See? You just read the secret language of electronics. You've cracked the code. So, it's a neat trick, but why is it so important? What's the big deal here?
Well, this is way more than just a fun fact. This simple, elegant code is pretty much the backbone of all modern technology. It's inside your phone, your laptop, the electronics in your car, but it's also inside critical, life-saving medical equipment, and even in the satellites that are orbiting our planet right this very second.
And that just perfectly captures the spirit of great engineering, right? It takes a universal problem. How do you label something vital but tiny? And it solves it with a system that is simple, visual, and understood all over the world.
So the next time you see a circuit board, you won't just see a random jumble of parts. you'll actually see a language. You'll be able to pick out those resistors and know that you hold the key to understanding exactly what they're saying.
And that kind of leaves you with a final thought, doesn't it? This one simple color code helps run our entire world. It just makes you wonder, what other secret languages and simple, brilliant codes are hiding all around us, in plain sight, just waiting to be cracked?